Hi, hello everybody. So this is the video dealing with section 2.6, rational functions and their graphs. And this is the third part where we actually put everything together and graph the rational functions. Now, I have to make one note known, which is the rational function that we're going to graph is going to be in this format where the numerator is a polynomial, the denominator is a polynomial, but they have no common factors. Meaning that if the function had common factors before, they were removed, and we're only going to graph the simplified version of the function. Okay, so this is easier. So this has to be made known. The second thing is these are the steps that we need to do or to take in order to graph the rational functions, but we don't need to do the first one. We're going to do or find the y-intercept first, the x-intercept. So the y-intercept is you're going to find f of 0. We're going to find the x-intercepts, and we find the x-intercepts by setting the numerator to 0 and solving for x. We're going to then find the vertical asymptotes, and the vertical asymptotes we find by setting the denominator to 0 and solving for x. Then we are going to find the horizontal asymptote. So you remember there was three possibilities for horizontal asymptote. So that has to be memorized. And then this is probably one of the key points is that we have to plot, we have to pick a point in each segment of the number line between x-intercepts and the vertical asymptotes to find exactly where the function is. So this is very important. Okay, so we're going to do these points through 2, 3, 4, 5, and 6 in order to graph these rational functions. Okay? All right, so I'm going to leave this visible because I want you to see exactly what we're doing. So let me erase this. So we have three examples. The first two are worked out in the book, and this is problem 71, which you can also verify. Now, these are all three are very, very good problems, so that's why I picked them. All right, so let's begin with example 5. And the very first thing that I'm going to do is I'm going to find the y-intercept. So we find the y-intercept by finding the value of the function at 0. So wherever I got x, I am going to replace with 0. Okay, then I have 0 minus 1. So obviously this is -1 over -1, which is 2. I'm going to find the x-intercept. And the x-intercept I find by setting the numerator to 0. And solving for x, right? So +1 on both sides. And divide everything by 2. This is my x-intercept. Then I'm going to find any vertical asymptotes. And the vertical asymptotes, we set the denominator to 0. And we solve for x. Obviously, +1 on both sides. And we got this. Important number 4, we're going to find any horizontal asymptotes. So the horizontal asymptotes we needed to remember, right? On the horizontal asymptotes is an evaluation of end behavior. So for that, we only take into account the leading term of the numerator over the leading term of the denominator. The equation of the horizontal asymptote is going to be y equals something. So in this case, the leading exponent of the numerator is 1. The leading exponent of the denominator is 1. When that happens, when they're both equal, the horizontal asymptote is the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, so that has to be memorized. Okay, so I got points 1 through 4, or, in the notation of the graph here, 2 to 5. So I'm going to plot all of these values into my graph. Okay, just keep in mind that the vertical asymptote and the horizontal asymptote have to be graphed as dashed lines. Okay, so here's the y-intercept. I'm going to plot the point right here. I'm not going to put any numbering because I don't know where the graph is going to be, and I don't want that to cross my graph. So the x-intercept is 1/2. Okay. The vertical asymptote is x equals 1. So now remember, this is 1/2. Here is my vertical asymptote, and here's my horizontal asymptote. So remember, this point right here is my y-intercept, which is 1. Maybe I should write the number. And here is my horizontal asymptote. Now remember, I don't need those tick marks, okay? Don't put them in because it's going to be extremely hard for you to graph with them on. So it's better to do it like I have here, an axis without tick marks. Now notice that the graph of the vertical asymptote is x equals to something, and the horizontal is y equal to something, okay? All right. Now let me just write this a little bit differently. I'm going to put it over here, x equals to 1. And I'm going to write here, y equals to 2. All right, so I have now several regions here in the graph. I have this region, I have this region, I have this region, and I have this region right here. So I need to pick points to know exactly where the graph is in those 4 regions. So I need to pick a point here somewhere to see if my graph is here or here. Okay? So let's pick a point. Let's pick this point. Now, and remember, this is x equals to 1, so I'm going to pick, x equals to 2, and I'm going to find out f of 2 to see where my graph is. All right, so I'm going to find f of 2. So here's the function. So 2 times 2 minus 1. 2 minus 1. So this is 4 minus 1, 3. 2 minus 1, 1. So obviously that's 3. So this is 2, right? X equals 2. So when x equals to 2, the function is at 3, which is here somewhere. So the graph is not here. All right? Now, because I have an asymptote here and here, I already know the behavior of this function. It's going to be this. I don't need to do anything else. I don't need any other points. This is the graph. Okay? Now, why is that? Well, these two lines, dashed lines, are asymptotes, so the graph cannot cross them. or hit them, right? Or reach them. So, and since the graph is a polynomial, we have to trace a curve approaching both ends of the asymptotes. So this is it. So it becomes very simple once you have the asymptotes in. Now I'm going to pick a point right here because I want to know where my graph is, right? Is it above here somewhere or is it below? So let's see. So I'm going to pick a point here. So I'm going to pick the point maybe -4. Okay. -4. So I'm going to do f of -4. So this is numerator -8 minus 1, -9. And -4 minus 1, -5. So this is positive 9/5. Now, we don't really care so much about the exact value here. We care that it's positive, above 1. Okay? But it's less than 2. Why do we care about being less than 2? Because 2 is my horizontal asymptote. So I know the graph is here somewhere. It's very, very important that you understand this. My graph can either be here or here. It cannot be in both places. Or why not? Because this dash line is an asymptote. The graph never crosses nor touches it. So it's either one or the other. Once I find f of -4, that it's right here, it's 9/5, which is less than 2, I know there is no graph in this region. Not only that, I know that my graph is here, that this is a y-intercept, and this is a root. And this line, this dashed line here, is another asymptote. So I already know the behavior of the graph in all of this domain. This is it. That is the graph. Okay? Let me just erase this for you to see. So in this case, after we plotted the y-intercept, the x-intercept, the asymptotes, we only needed 1 point here and 1 point here to completely define our curve. And this is usually all that it's needed to graph these rational functions. All right. It seems very complicated, but you can see the work is very minimal, and we usually have to pick 1 or 2 points. All right, so that's the first example. Let's take a look at the second one. I'm going to erase it. And again, if you need it, you can always stop the video. Let's take a look at the second one. And we're going to begin by, again, doing the y-intercept first. The y-intercept we find by evaluating or seeing what f of 0 is. So 3, 0 square, and then 0 square minus 4. So obviously the numerator is 0, -4, which is 0. Then we're going to find the x-intercepts, and we find the x-intercept by setting the numerator to 0 and solving for x. 3x squared is 0, so divide both sides by 3. Take the square root of both sides. Also 0. We're going to find any vertical asymptotes. Now the vertical asymptotes, we set the denominator to 0. Okay. So we can factor, this is difference of squares. Now I am not reviewing any factoring techniques. So if you do need to review factoring techniques, go online or go to your previous course and review those. Now, by the zero product rule, set this factor to zero, set this factor to zero, and solve for x separately. So in this case, plus 2 to both sides in the left case. And in the other case, negative 2 on both sides. So I have two vertical asymptotes. And then last, we find the horizontal asymptote. So again, for the vertical asymptotes, we needed to remember that this is end behavior. So I locate the leading term with the highest exponent on the numerator, leading term of the highest exponent in the denominator. And if they have the same exponent, which they do, then the horizontal asymptote would be the coefficient of the numerator divided by the coefficient of the denominator. So in this case, again, so remember, for vertical asymptotes, the equation is x equals for the vertical asymptotes. For the horizontal asymptote, the equation is y equals, okay? Don't mix them up. All right, so now I have every piece of information that I need. I will plot all of these values. So here's my y-intercept, which also happens to be a root. And I have two vertical asymptotes. Remember, the asymptotes have to be graphed as dashed lines, all right? The graph of the function doesn't touch them. And I am going to plot the horizontal asymptote. Okay. All right, so this is a very good example. So I have one region, 2, 3, 4, 5, or 6, right? This whole thing is 5. This whole thing is 2. We need to know where the graph is. So I need to pick a point in each of these regions. I'm going to delete them now here. So I am going to pick a point right here. I am going to pick a point here. Maybe one here and maybe one here. So in this case, I need to find 4. All right. So I'm going to begin right here. So now this is x equals 2. So I'm going to pick the value of 3. X equals 3. So I need to find f of 3. F of 3. So 3 square. 3 square is 9 minus 4, right? So then I have 3 square 9, 3 square 9 times 327 over 9 minus 4, 5. Now, we don't really care about the exact value of this thing, but we only care that it's positive, and it's certainly greater than 4, right? Actually greater than 5. Which means what? Take a look at our graph. The function is here somewhere. It's not below 3. The only thing that we need to know, is it above 3 or below? Well, Professor, why is it above 3? Why 3 so special? Well, the 3, number 3 is special because the asymptote is a 3. So I know that my graph is either here or here, but not both, right? Not in both places. It's not possible because an asymptote means the graph of the function cannot cross them. So since the point is already here, I know that the function looks like this in this segment. There's nothing here. There's nothing here. Okay? Now we're going to do the same thing here maybe for -3. Okay? I don't really need to do the -3 because the function is a square function, so the result's going to be the same, but I'm going to do it anyway so that you can see. So f of -3, it's going to be the exact same thing. 3, -3 squared, and -3 squared minus 4. So again, the numerator is 27. The denominator is 5, which is obviously positive and greater than 5. So it's here somewhere. And because these two lines are asymptotes, the graph looks like this. All right. And for the same reasons, I know that the graph cannot be here because of the asymptote line. All right, so that was very easy. I got the two pieces of the graph on their tails. Now I need to know where the graph is in the middle, right? So I have 2 points to pick. I need to pick a point right here. And now remember, you cannot choose -2 because -2 is an asymptote. Okay, so it has to be bigger than -2. So I'm going to pick -1 here and 1, right? So let's find the value of the function at 1 first. So 3, 1 square, 1 square minus 4, which is 1 minus 4. So 3, and this is -3. So this is -1. So at 1, the function is here somewhere. Okay. Now we can do the same thing with the -1, but because the function is quadratic, the value is going to be exactly the same way. So here is your -1, and the value is also going to be -1. So maybe doesn't help us too much. Not quite sure where maybe has to go. I mean, you understand that these two lines are asymptote, and this location is a intercept. Now, what does it mean to be an intercept? It means that the function has to go through it. Okay? All right, so let's see if we understand exactly what to do only with these 2 points. This is -1. This is 1. I found the value of the function here and here, and these two lines are asymptotes. So the function has to go like this. Okay, there is no other way. Because of the asymptote. So if we have asymptotes at some point in time, the graph must go toward it. Okay, toward them. So this is the graph for the rational function in example 6. Now, if you're not sure, you can pick a point very close to -2 on either side. Okay, don't pick a value here because you already know here the function is up there. okay? And confirm that for something very close to 1, like 1.9, the value is going to be very negative, confirming that the graph of the function is going toward the asymptote. Okay? All right, very good. So let's see the last example. The last example is very good. 71. And again, we begin with the y-intercept. Y-intercept is f of 0. So 0 plus 2. Divided by 0 squared, which is 0, plus 0 minus 6. So this is 2 over negative 6, which is negative 1/3. Again, as you see, we're not really concerned with the decimal value of this. We're just interested in the negative. Okay. X-intercept. The x-intercept is we're going to set the numerator to 0, and we're going to solve it for x. Okay, obviously minus 2 on both sides. Now, also keep in mind as I'm doing this, if this is a question on the exam, this is exactly the kind of work that you would show us on the exam, all right? That's all that's needed as proof of your work. Now, let's do the vertical asymptotes. So for the vertical asymptotes, we set the denominator to 0. And we solve for x. So this is a trinomial where we have to factor the trinomial. Now, again, I'm not reviewing, factoring techniques, but this is going to factor like this. And the product is negative 6, and the sum is positive 1, and then we're going to set that to 0. Now, by the zero product rule, you set each factor to 0 and solve independently. On the left equation, you add 2 to both sides. On the right equation, you subtract 3 from both sides. Okay, so here are my two vertical asymptotes. And the horizontal asymptote, again, we look at the leading term, the term with the highest exponent on the numerator, and we look at the leading term, the one with the highest exponent in the denominator. Now, in this case, the exponent of the denominator is bigger than the numerator. When that happens, the horizontal asymptote is y equals to 0. So remember, the three cases for the horizontal asymptote need to be memorized. This is one of the cases. We saw the other case in both examples 5 and 6, where when they are equal, then the vertical asymptote is the ratio of the leading terms. And the case that we didn't see is if the numerator exponent is higher than denominator exponent, and in that case, there is no horizontal asymptote. Okay? So in this case, since x to the 1 is smaller than x squared, the horizontal asymptote approaches 0. Or it is y equals to 0. Okay, so I have all of the information I need. It's always these 4 things that we need to find, and then we will plot them in. So first, the y-intercept. So I'm going to say that my y-intercept is here, negative 1/3. And I am going to say that the x-intercept is here, negative 2. I'm not plotting the whole x and y coordinate because this might disturb graphing the function. My vertical asymptote, I have 2. I have x equals negative 3. and I have x equals 2. And I have that y equals 0 is another asymptote. Now, this is what I want you to see. Something very interesting happens here. This is y equals to 0. Now, here is an issue. This is a horizontal asymptote, which the definition is the graph of the function never crosses or reaches or crosses. But yet, here is my x-intercept. So how can it be that the asymptote is passing through the root or the x-intercept? That cannot be. It's not possible. Now, what does that mean? It means that the asymptote is the horizontal asymptote. It's only here and here. It cannot be where the roots are. So there is no horizontal asymptote in the middle. Okay? And if you want, you can pick a couple of points and you will see. So uh, here's my root, x equals -2. All right, so I have a couple of regions I have to test. I have these 6 regions I have to test. Okay? So let's test them all. All right, so first I think I'm going to pick a point here somewhere for x. So let's say that x equals 3, and I'm going to do the same thing right here. Now, don't pick -3 because this is the other vertical asymptote. So pick, x -4 right here. Okay? Or you can pick 4 for both. It's okay. It's perfectly fine. So let's find value of the function at 4 and then -4. Okay, so here's my function. So 4 plus 2, 6. Now, and then I have 4 square, 16, plus 4 minus 6. So I have numerator 6, and I have denominator 14. All right. Now, all that matters is that this value is positive. Meaning what? Now, remember, this is a asymptote. This is an asymptote, which means that the graph is either here or here because the function cannot cross it. If I found out that it's already positive, that means the graph is not below the x-axis. It's here somewhere. And since this is a vertical asymptote, again, the graph on this region is going to look like this. Okay? Now, let's do the same thing for -4. So -4 plus 2, -2, -4 square, 16, plus -4 minus 6. So I have -2, and I have 16 minus 6, 10, right? Minus 4, 6. So this is negative, right? So let's just make sure I didn't make any mistake. -2. So this is 10, 6. Yes, -1/3. So now, as before, let me just erase this point. For -4, let's say that this point is -4, the graph is below, which means the graph is not here because I have y equals to 0 as a horizontal asymptote, which is great, because that means I already know the behavior of the graph. Okay, so the behavior of the graph is like this. Okay. So that segment is also done. I'm going to erase this for now. All I need to do now is I need to find the behavior of the graph in here. So if you want, you can pick a point right here somewhere. Right, so maybe 1. So let's find f of 1. So 1 plus 2, 3. 1 square, obviously I'm evaluating this function. 1 square is 1 plus 1 minus 6. 2 minus 6 minus 4. So this is obviously less than 0. So at 1, I am here somewhere. Actually, I'm here somewhere, right? Because negative 1 over 3 is negative 0.33. Now, so this is enough. I didn't even need this point, right? I didn't need the point 1. Now, here's why. This is an asymptote, meaning the graph has to get closer to it. This is an asymptote, which means the graph has to get close to it. This is the y-intercept, and this is the x-intercept, meaning what? The function has to cross it or cross them. Now, can you see now how to graph the function in the middle region? Well, it has to go toward the asymptote. It has to pass through the root. It has to pass through the y-intercept, and he has to go toward the other asymptote. There is no choice. So this is the behavior of the graph in this middle region. Okay? I didn't even need this x equals 1 to find out. Or maybe I did, because maybe you could say, is it possible that he may be going up? All right. So we plotted a point x equals 1 to find out. Okay. On the other side, I didn't need to, because I know that it had to go up, because the y-intercept was smaller and the x-intercept was forcing the function to go up. So this is how you graph these rational functions. All that we need are these points 2, 3, 4, and 5, and 6 to graph. We don't need the symmetry. It's not necessary. You can do without, by plotting these additional points as necessary.